Hi, I'll be talking about the CSS modules work that we've been doing in Google+. Modules is a problem that's not just applicable to Google or Google+. It's a problem that's faced by all very large applications that have lots of features. So this is just a sampling of some of the top-level pages on Google+. And within each of these pages, we have tons of features. And lots of features add up to a lot of JavaScript and a lot of CSS. And as you can see from these numbers here, we have a ton of CSS. And so we have a problem to solve. Again, and this is not the only problem. We do have the problem of big CSS, and we want our initial page load to be super fast. But in addition, a problem we've been facing a lot over the last year has been that kind of broken UIs. A lot of our CSS is manually curated in build files. And this is brittle, and it's prone to reordering. So this is the second problem that we're trying to fix. So module systems is primarily solving the problem of size. But building a module system is much simpler if you absolutely had no shared code in your site. So let's say every page of your site is completely independent and doesn't share any code at all. Then it's fairly straightforward to build a module system. Every page becomes its own module, and you load it as you go. But in reality, though, we do have a ton of shared code. And if you don't have any shared code, then you're definitely doing something wrong, because styles should be shared across your site. So building this dependency system turned out to be a big win on its own. It's vastly improved the CSS development experience, because now we can rely on the framework to ensure the correct cascade ordering. And developers don't have to keep fighting specificity anymore. So this project is a work in progress. We haven't completely launched to all of Google+ yet. We have launched modules to several pages on our site, and we've seen significant improvements in CSS size. And the preprocessor we use internally in Google is called Closure Style Sheets. And internally, we call this GSS. So if I accidentally say GSS in this talk, I really mean CSS. So the step one to build an effective module system is to know what the shared code is. And this is not always trivial to identify. Sometimes you might notice the button and a menu look similar, but it's not easy to see exactly what is similar. So we can at least start with the very obvious. Let's start with the exact same UI elements that keep repeating over and over again. And these are things like buttons and icons and what's famously called the media object. And we have a ton of these repeating patterns in Google+. So Google+ is a social network. And the primary thing on the main page are these posts, which are contained in what are called cards. And every post has the same characteristics. Every post has an icon with the name of the person posting. It has buttons for upvoting and resharing. And it has comment activity. In addition, on the top left is what we call the share box. If you wanted to share something with your network, this is where you would start typing. This is a completely different page. It's my profile page. And you can see that the top right card is different. But again, the common theme here is there are posts. And the posts have the same characteristics. And again, we see the share box. And you can see the common elements outlined in red. Yet another page on Google+. This is called the community page. It's a forum for people of similar interest. Here it's photography. And again, it has unique elements, like the left panel and the right card. But again, posts and share box. Photos page, at first glance, it looks completely different. But if you look on the right panel, you see the same repeating components again. So you get the point. We have a ton of shared components all over our site. But this is not all. In addition to this, we have lots of shared styles across Google+. And these are things like fonts and colors and layouts. And then in addition to that, we have lots of common styles across all of Google. And these are things like buttons, checkboxes, dialogues, menus. This is so that as you navigate different Google products like Map or Search, you get a somewhat consistent look and feel. And by the way, everything I showed you so far is developed by completely different teams. So we have these somewhat competing goals of all these teams wanting to split their code by project boundary, but we want them to share all of these common styles. So this is all the more reason why we need a dependency system, because we want a systematic framework and not rely on developer discipline. So we saw how the home page and the community page share some code. Like in this case, they share the code for posts and ShareBox. In addition, they have their own unique elements. We definitely want to write all of the shared code only once. We want to download it only once to the browser. And we want to download the minimum possible CSS. So let's consider the larger problem of code that's downloaded on the browser. And this is not just CSS, but includes everything the browser needs to render the page, including templates and JavaScript. So for the home page we've already seen, we need code to render posts, render the ShareBox, and other homepage-specific elements. So one of our main goals here is when we first visit the home page, we want the page to be super fast, just load the minimum code needed to render just that page and nothing more. And then later, when we go and visit the community page or some other page, then incrementally load code just for the features needed for that. Now, it turns out there is already a solution for this in JavaScript, and it's called JavaScript Modules, and it solves exactly this problem of incremental download. And any JavaScript developers in the group might be familiar with AMD or CommonJS. And last year, my coworkers from Google, Malta, and John unveiled the open source Google module server. However, there is absolutely no solution for this in CSS yet. And the question is, can we potentially use the same solution? There is a catch, though. In CSS, we have the problem of safety. So in this example, when I go visit the community page after the home page, if I'm not careful about how I write my code, the styles that I load later can override the styles I've loaded earlier. So it's possible that I break the UI for the home page. So now we have this additional goal that as we incrementally load CSS, we want absolutely no regressions on previously shown pages. So we're coming to the conclusion that CSS is not as simple. We have the safety challenge that I already mentioned. In addition, we know that we have a ton of shared code. We want a dependency system, but CSS doesn't have a notion of dependencies. And almost every other language seems to have this. And this is require in CommonJS or import in Java and Python. So how do we depend on what we need? And how do we depend only on what we need? A recap of our goal here is just deliver the minimum amount of CSS, do it incrementally and safely. And the challenges here are bundling the CSS with its dependencies, downloading it as needed, and safely composing it. So we are essentially saying we need a module system. Because bundling CSS with deps is really what a dependency system does. And downloading and composing is what an assembly and serving system does. So let's look at each of these challenges, starting with the first one. So we define a CSS module as a bundle of CSS that supports a page of our site and is downloaded together. And we've already identified CSS shared code and dependencies. And these are things like CSS from the shared components, fonts, and colors that are expressed typically as constants. And in addition, we have a lot of common CSS libraries. And these are, in our case, these are Google-wide styles. So let's stipulate upfront that the naive solutions don't work for our case. We cannot just use a CSS at import on every page we visit, because this would just duplicate download all of that shared code. And you've seen we have a ton of shared code. In addition, we want to include only what we need. For example, different pages use different variants of the ShareBox I showed you. Now, if the profile page wants 1 out of 7 variants, it should only include that one and nothing more. Another non-solution for us is we cannot take every single style that's shared across our entire site and bundle this together into a giant shared deps module. This module is going to get very large and unmaintainable very quickly. So let's start out with figuring out how to express dependencies in each of these cases. With shared components, because we write styles in a completely separate style sheet, how do we even know which CSS belongs to each of these? While we don't know exactly which CSS belongs to this, we do know what templates are needed to render those components, and we know what JavaScript is needed to make them interactive. And those things, the templates and the JavaScript, can in turn point us to the CSS that they pull in. So essentially, what we are saying is, let's bundle template JavaScript and CSS into components. And this starts to sound a little bit like web components. So this idea is similar to Nicole's CSS Legos, which is identify shared widgets, create reusable groups of CSS. The additional concept we're bringing here is we want to bundle templates and JavaScript together and create self-contained components. And essentially, we want the framework to do all of the heavy lifting and not rely on developer discipline, because the top priority for developers is to launch their features. So to create these self-components, express dependencies from the template to the CSS and from JavaScript to the CSS. And we've created syntax for both of these. So for the templates case, we use closure templates in Google+. And we've come up with this require CSS annotation that you can just add to your template, pointing to the GSS namespace. And similarly, we have an annotation that we use in our JavaScript for the same purpose. And this can just as well be expressed with AMD syntax. So at the end of this, after we have identified these components, bundled them together, and we are expressing dependencies on them, at the end of this, we have a component dependency graph for this page. And once we do this across our entire site, we have a complete component dependency graph. The second type of dependencies we identified are things like fonts and colors. And these are typically expressed as constants for us. There's established syntax for this in most preprocessors. This is at import in SAS. And we use closure style sheets. And our syntax is provide and require. And this fits in really well with our CSS dependency graph. So let's say the profile page wants a separate set of constants from the home page. It can depend on just those constants. So this is an example of the provide require syntax for constants. So in this case, we have a profile base CSS namespace that is exporting a constant for profile update background color. And if something else wants to use that constant, all it has to do is say at require and use the constant. So now we are expanding our CSS dependency graph to include these common fonts and colors. And essentially, all of our constants and mixins become part of this dependency graph. We haven't covered what we're doing with common CSS libraries yet, but we'll come back to that soon. So moving on to the next challenge here, how do we safely compose the CSS in the browser? But to set the background for this, I have to reiterate kind of the basic points of CSS, which is order and specificity. CSS is inherently order dependent. If you have base styles and you have overrides for these styles, the base styles must be ordered before the overrides. And specificity can trump order. So in this example, if I have a div wrapping hello world text, and I have two classes on it, blue and red, with the colors blue and red, the hello world is going to show up in blue. And the reason for this is that the cascade order dictates the styles applied, not the classes in HTML. However, if I added yet another class to this and added the additional class in my CSS file, that changes the color to red. This is because I have just bumped up the specificity of the red class. And in general, this is not a great way of overriding, because every time you wanted to override something, if you're going to bump up the specificity, then you're essentially fighting it on the next override. And this is famously called the specificity wars. So we generally want to use a cascade to dictate styles and not specificity. So thanks to the work that Nicole has done on object-oriented CSS, there is a body of guidelines, and we've found these to be really accurate from our own GSS development experience. We want to minimize the selectors we have. We want to reuse as much as possible. We want to keep specificity low, and we want to have rules of the same strength. And we want the cascade order to override styles, not specificity. But ideally, we want our framework to do all of this for us. The framework should enable us to create simple selectors and rules of equal strength, and basically correctly order the cascade so the developers are not fighting specificity. So let's take the concrete example of a button. We have a button which has some common styles, and different pages want to override in a slightly different way. And let's say for this example, they want to change the color for all these different cases. There's many ways to override styles, and each one has its pros and cons. And we're going to quickly look at some of the common ways to override styles. The typical way to do this is you should ideally be extending the standard button class with your own context-specific button class. And often, programmers might start out with a compound selector for this. So you would write profile button.standard button. And we've already said that this is not the ideal way to do this, as it's prone to clashes. If you want further overrides of that same style, let's say you want different styles in profile if that button appears in the header versus the sidebar. Descendant selectors is another way to do this. Here, and this is definitely better than compound selectors. But to some extent, you may be tying your CSS to a predefined HTML structure. You might use tools to do this. Mixins are a pretty standard thing in most preprocessors. And if you used a mixin, it would automatically expand the styles in line. So you're essentially getting rid of the standard button class. And the problem with this is now you are duplicating all of these styles in each context. And we've already said we don't want any duplication. Yet another way to do this is use the SAS extend with a placeholder. And this compiles to something like this. And this is a vast improvement over mixins. However, this is not our ideal solution with a dependency graph, because now we have this one rule which has all of these feature-specific selectors tied together. And now this rule is going to show up in some shared module in our dependency graph. And ideally, we just want to keep feature-specific code in separate modules. And finally, a way to do this is to simply write the overriding styles. Keep standard button as it is, and it's already provided in our shared library anyway. And let every context just add its own style. But here now, we need to rely on the correct cascade order. This is, in fact, our preferred way to override styles in Google+. And we have a syntax for this, which is provide and require. So if profile button needs to be ordered after the standard button, all it has to do is @require the standard button. So we are essentially expanding the semantics of @require to include ordering now. And we've considered some alternatives here, like expressing this ordering in JavaScript and templates. And this wasn't as pretty, because first of all, we have to do it in both places. And now there is CSS ordering semantics in templates and in JavaScript. And we also like the solution because it meets our requirements. We minimize selectors. We have rules of equal strength. We still haven't covered how to handle style overrides for components yet. So first of all, I want to demonstrate that using components with a dependency graph actually guarantees correct cascade order as well. So let's say I have many widgets on my side, and they all want to use a common component, like an icon. So this will basically map to some dependency graph if we are using components. And the styles would show up in the graph. And eventually, we are going to flatten this dependency graph into the cascade. But we still preserve the order. So all the ordering, the arrows that were there in the previous graph, are preserved in this cascade. And the framework will now create the correct cascade from this graph. We still haven't said exactly how we are overriding styles, though. And well, the two ways we do this most often in our case are either using additional classes or descendant selectors. If the component is going to be mostly overridden in almost every context it's used, then it's better, well, we think it's better to simply add an additional class. And this means that the overriding context has to plumb the additional class into the component's template. But this is fine because it's essentially exposing an API for the override. The other way we do this is with descendant selectors. And this is still fine, because we're not really tying this to some predefined HTML structure, per se. We are tying it to a context. So far, we've covered the types of CSS dependencies in our system. And we've shown you the syntax we use to express these dependencies. And we've shown you how to override each category. And we've shown you what the cascade order. So now we've covered all our categories of depths. And we essentially have a complete CSS dependency graph that includes all of our shared styles and components, fonts and colors, and the Google common CSS libraries, et cetera. So this covered our dependency system. We have namespaces. We have a way of expressing dependencies. So now we move on to our assembly and serving system. So I've already touched on how modules get how a dependency graph gets flattened to a cascade. And here, the only additional thing is that we also identify modules. So you're identifying granular units of modules in this graph. And then you compile the CSS to these modules. And then the modules get translated into a cascade. So a module is a CSS grouping downloaded together. And we always download the dependencies for every module that we load on the browser. And this is analogous to our notion of JS modules. And so we are really trying to sort of piggyback on the download system that we already have for JS modules. Now for serving, it pretty much works in the way you would expect. You have the community page depends on the modules for the share box and the posts. And when it wants to render those modules, in turn, will pull in all the other modules that they depend on. And so this will include your buttons and your comment widgets and your fonts and common styles, et cetera. And then later on, when we visit the home page, we only additionally download just the modules needed for the home page, because we already have everything else. So the important point with this download system is that it also ensures safety. So we mentioned earlier how the later page has the potential to override the styles of a previous page. But here, we've already solved this problem by doing all of this hard work of creating this dependency graph. So now there is no question of home page styles overriding the community page styles, because all of their common dependencies have already been downloaded. So in summary, this system is solving both of our original problems now. We are solving the problem that our initial bundle is really big and it's really slow, and we have manually curated CSS that can get reordered and break our UI. And these are some open source resources. We use Clojure style sheets. And this has our syntax for @provide and @require. And we use Clojure templates, which doesn't have our syntax for require CSS yet, but will in the future. And that is all. Thank you.